Welcome to the Propositional Logic unit of my Practical Introduction to Logic. In this tutorial, I will introduce you to propositional logic, talking about the fundamentals of propositional logic and how it works. And we'll begin our exploration of propositional logic with truth tables, and then we'll proceed to the notion of formal proof, and we'll learn how to construct formal proofs of validity. So let's start with the idea of a proposition. A proposition is essentially an assertion about the world that has a truth value. And there are two truth values, true and false. We used to call propositional logic propositional calculus. And the reason for that is because essentially the idea of propositional logic is based on two fundamental concepts: the idea of a proposition as the bearer, as it were, of a truth value, and functions. The notion of a function in calculus is where we have some values that are given to a function. The function does something with those values and then outputs some particular value. So let's look at those two notions first, starting with the idea of a proposition. So a proposition is essentially a claim about the world. So suppose I claim it's raining in Tanzania. Let's use T to stand for it's raining in Tanzania. I picked Tanzania only because it's very far away and I don't have immediate access to the weather conditions. But that's useful because the idea of a proposition is that it's an assertion about the world that is either true or false, even if we can't pin down exactly which truth value it should have. At the moment, I have no idea whether it is or isn't raining in Tanzania. There are some effective procedures that we might adopt to try to figure that out, but that's not needed in the present moment. All we need to know is that a proposition is an assertion about the world, and as an assertion about the world, it has a truth value, and the truth values are either true or false. Now, how is that different from other types of language? Well, if you think about it, we have lots of other uses of language other than a function that tells us something about the world or makes an assertion. Like what? Well, like questions. It would make no sense at all to say true or false. How tall is Matthew? That just doesn't make any sense. How tall is Matthew is a question to elicit an assertion about the world. And what the question elicits is an assertion. It's a proposition, and that proposition has a truth value. So suppose I ask the question, how tall is Matthew? And someone says Matthew is 5'11". Let's use F to stand for Matthew is 5'11". So Matthew is 5'11" is assertion about the world. It's an assertion about the condition that the world is in at a particular moment. And as such, it has a truth value of either true or false, depending upon, surprise, surprise, whether I am in fact 5'11" or not. So the way we think about the assertion is that it is one among a number of different types of uses of language, but it's the one that we're most concerned with in logic in general because we are interested in arguments, and in propositional logic in particular because propositions are assertions about the world. All right, so now let's back up. Suppose we have an assertion about the world. I have a headache. Let's use a capital H to stand for I have a headache. Now, quite often in ordinary life, we don't just utter single claims like I have a headache. We often want to connect those claims with other claims like I have a headache and I'm hungry. Let's use U to stand for I'm hungry. So I have a headache and I'm hungry may be an assertion that is implying that there's some causal connection. Some people get headaches when they become hungry. But the point of this discussion for us is just that we have two sort of individual assertions. I have a headache and I'm hungry. The two individual assertions that are connected together by something that connects propositions together. One of the things to notice about this larger amalgamation is that it is also a proposition, because presumably I'm hungry and I have a headache is an assertion about the world that's either true or false, depending upon the condition that the world is in at a particular moment. So, what are the situations that would have to be the case to make this overall utterance true, given the fact that each proposition can only be either true or false? Now, again, we may not know what the truth value is, but a genuine proposition is always going to have a truth value, even if we don't know what it is. So let's think about this for a minute. Suppose I am hungry. So we'll put a yes here. Suppose I am hungry, and I also do have have a headache, and I'm also hungry. In that case, the assertion, I have a headache and I'm hungry, is true. Now, what if I do not have a headache, but I am hungry? In that case, the assertion is false. The assertion overall. It's still true to say I'm hungry, because that's the state that the world is in. That's what we're considering here on this second set of possibilities, right? But because I do not have a headache, the assertion, I have a headache and I am hungry, can't be true, because for it to be true, we're starting to realize the and is telling us that both of these two claims on either side ought to be true. So let's find out. What if it's true that I have a headache, but it's not the case that I am hungry? In that case, again, I'm hungry and I have a headache is false. As a whole, the whole utterance is false. And our final possibility is, what if I do not have a headache, but I'm also not hungry? In that case, clearly the overall utterance is false. So what we've done here in a very intuitive way is we've looked at two claims about the world. They're propositions. These two propositions can either be true or false, depending on the condition the world is in. And then we also join these two propositions together with something kind of like an operator, a function, and we looked at what that function outputs depending on what the inputs are to that function. In other words, this is exactly the sort of operation that I was talking about when I mentioned functions like f of x. So f of x is a function, and what it says is that if you stick a value in for x, so we put some value in here, if you stick a value in for x, this function is going to basically output some other value. Now, the cool thing about propositional calculus is there's only two input values for propositional calculus, true and false. So in the language of mathematics, we could say that is the domain. The domain of propositional functions is only the set of values true and false. And because what we're looking at is joining propositions together to create new, larger propositions, we can also say that the range of those will be true or false. So domain is a fancy word for inputs. Range is a fancy word for outputs of a function. But in propositional calculus, we can talk about the function of operators like and as taking inputs of either true or false and giving us outputs of either true or false. So if we were to go back through our example about the proposition, I have a headache and I'm hungry, what we could do is in all of the situations where there are checks, we could change that to a true, just like this, true. And in all the situations where there are x's, remember x means that it isn't the case that whatever the proposition is we're considering, we can change that to false. Now we have the complete picture about how and behaves. Complete picture, why? Because there are no other possibilities than a claim about the world either is the case or is not the case. That maps onto true and false for our purposes. And we've exhausted all the possible pairs of conditions that could be the case for the two propositions, I have a headache and I'm hungry. So because of that, each of these rows tells us one pair of conditions that might be true. In other words, it might be true that I have a headache, and it might be true that I'm hungry, in which case it has to be true that I have a headache and I'm hungry. Another condition is it's false that I have a headache, but it's true that I am hungry, in which case the overall proposition, I have a headache and I'm hungry, is false, and so forth. You get the idea. So essentially what we've done is looking at the fact that individual propositions, which are assertions about the world, take truth values, and I know it's not very well named because there are two truth values and they're true and false, so it's a little bit misleading, but that's the term that we use, truth values. So each individual proposition has a truth value, and then when we use certain kinds of operators that are like functions, in fact, we could even call them truth functional operators. What they do is they take the individual values of what's given as inputs, like true for I have a headache and true for I'm hungry, and they give us an output. Here's the output column. They give us an output based on what those inputs are. That is the fundamental idea behind propositional calculus. So now, in our next tutorial, I will talk about all the ingredients that we're going to work with in the system of propositional calculus, and then we'll be in a position to start on the road to constructing truth tables and proofs.